Hi, I'm Chandler. The problem that my engineering team has solved is recycling 3D printed plastic. Any scrap that you make out of 3D printers shouldn't be thrown out, it should be recycled. And our team has come up with a great solution on how to do that.
I'm Zach. The solution that we came up with is a four-part design for recycling plastic. We have 4 subsystems consisting of the grinder, the extrusion, HVAC, and the spooling system.
Hi, I'm Ethan. Our product is a very simple design that is both compact and easy to use for even inexperienced users. As you will see in the rest of this video, our system uses a 4-part design, and we will explain that step by step.
Hey, I'm Mitchell, and the recycling of 3D printer filament is crucial for the environment. If we could recycle 3D printer filament, that would drastically reduce the amount of plastic waste we would produce. In addition to not only being great for the environment, it also cuts on costs.
The shredder that we created for our final prototype uses an electric planer positioned in such a way that it grinds and collects plastic scrap. We constructed the base of the system out of wood. We built a chute for plastic to meet the blade of the planer using wood and plexiglass. Any openings were sealed with silicone. This system demonstrates full functionality per our PDS requirements. It fits the volume of plastic scrap to be grinded that we required. It cuts plastic with a cylindrical blade on a motor and is sealed with silicone to prevent any scraps from entering the environment. Also, it can grind the plastic into shreds of 1 to 2 millimeters. This shredder also has the ability to regrind large grinds to ensure they get into the 1 to 2 millimeter range. We sort out the ideal sized grinds from the large grinds in the hopper with a mesh insert. This makes sure that only small grinds pass through to the extrusion system. On the base of the shredder, we mounted a switch to safely turn the motor on and off. This is a very effective and simple to use design that we think any user will be more than comfortable to use.
The extrusion system we created for our project consists of a 3/4 inch DeWalt auger that is used in a drill. This auger is a versatile tool that is readily available and commonly used in the industry. We modified it by connecting it to a 15-in-1 gear EMA 23 stepper motor that uses a TB660 motor driver programmed by an Arduino board. The auger is placed through an iron NPT pipe that is mounted to a flange and has a brass cap at the end of it. The brass cap is drilled with a drill press to achieve a precise hole for extrusion. Within the extruder, a holder is placed before the flange that has the auger rest over it. The way this was designed was to ensure the shreddings do not go underneath the auger and are guided through the NPT pipe. This design ensures a smooth and efficient flow of the melt, preventing clogging or uneven extrusion. The Arduino was reprogrammed to customize the extrusion process to meet our specific requirements. By changing the pulse width duration, we can adjust the torque and the speed of the motor. This allows us to optimize the extrusion process for different materials and filament diameters. The extrusion system also features a high-quality temperature control system that ensures precise and consistent temperatures throughout the extrusion process. Our extrusion system provides a cost-effective solution for producing high-quality filament. By utilizing readily available and affordable components such as a DeWalt auger, we were able to keep costs low while maintaining high level of performance. Our system is more affordable than custom augers or other commercial extrusion systems, making it a valuable addition to any filament production.
The HVAC system includes the heating and cooling of the materials and plastic during the extrusion process. The heating system includes 2 ceramic heating bands with built-in insulation. These bands fit snug around a steel barrel that conducts the heat inwards to the plastic being melted. The cooling system includes a powerful AC-powered fan mounted directly above the middle of the barrel. The HVAC system is controlled by a temperature controller that is connected to a solid-state relay. A surface-mounted thermocouple is also placed at the center of the barrel to monitor the temperature conducted at the middle. This temperature sensed by the thermocouple determines whether the relay sends power to the heating bands or cooling fan. Switches are also connected to each part of the HVAC system for an even more controlled system. The system fulfills the PDS requirements by having switches for the user to shut down in case of overheating, and it also alarms the user on their controller display if the system overheats. Also, power consumption is well below what is stated in our PDS requirements, and the bands are also insulated. The melting temperature of the plastic can also be easily achieved.
The spooling system includes a direct current motor, an adjustable speed controller, and a mount for the spool that provides easy accessibility when changing spools. In between the extrusion nozzle and the filament spool, there is a roller that provides support in case the extruded filament slacks and helps maintain proper tension. The 12-volt DC motor spins slowly with enough torque that in combination with the speed controller can spool the filament very consistently under proper tension. The adjustable speed controller has more than enough precision to accommodate the speed setting of the extruding motor's highest and lowest speed. The assembly of the spooling system was carefully constructed such that the filament coils directly along the inner cylinder and avoids sticking and tangling with itself. The spool is approximately 8 inches above the base, which gave the filament a much more ductile property compared to the more brittle version when it was located 5 inches from the base. This lends to producing a more ideal end result of filament as it is spooled smoothly, passing the filament into a 3D printer without any issue. The spooling system fulfills all requirements of our project design specifications, which are as follow. Have a motor-controlled spooling system where the plastic can attach and wrap around a spool.